పర్లేదేనా. Good afternoon, sir. Mr. Suresh.
Very good afternoon, sir.
Good afternoon, sir. This is myself, this current video. You can on your video, sir. Please.
Yeah. Very good afternoon, sir.
Good afternoon, sir. Myself, Dr. Sunil Kumar, head of the department, EEE.
Pleasure to connect, sir.
So thank you, sir, for accepting our invitation and welcome to the 6-day faculty development program. Your experience will be useful to the participants, those who are there here. Thank you for participating. And also, I welcome all the participants to the last day and 6th day of the event. I request Mr. Guruswamy to read the profile of the Mr. Suresh Vengali, Senior Commissioning Manager from Korea.
Yeah, good afternoon. Mr. Suresh Vengali is working as Senior Commissioning Manager from Samsung Heavy Industry Services of Australia. He holds high voltage electrical safety level 2 certification and recognized as professional engineer from Engineering Council of India and membership from the Institute of Engineering and Technology. The major projects handled by Mr. Suresh Vengali are BPMD2 Floating Production Unit, which is an ongoing project in which his position is Lead Electrical Commissioning Engineer, and Floating Central Processing Facility, which was completed in April 2017 with the role of Electrical Commissioning Engineer, and also in Reliance Jamnagar Refinery J3 project with the role of Manager Electrical Design, and 6MTPA Integral Steel Plant as a role of Senior Electrical Engineer. So Mr. Suresh Vengali is a professional electrical engineer of Engineering Council of India with around 10 years of experience and involved in design commissioning phases of oil and gas, offshore floating production platforms and onshore, and steel industry projects and power projects. Since August 2013, Mr. Suresh is working in Samsung Shipyard as manager, senior commissioning manager for offshore production platforms associated with Samsung Energy Private Limited, and as a social responsibility and to bridge the gap between industry and academia, he also delivers guest lectures to many budding engineering students on the topic of electrical engineering career path in design, construction and commissioning fields with an example of DC system in industry. So with this, I request you, sir, to continue with the presentation. And few more things to add to his resume is he is the co-founder of the Engineers Factory Forum, which deals with industry and academic interactions. And he has delivered guest lectures at various renowned colleges all over the India and all over the globe in order to encourage electrical engineering students towards the core industry. So with that, I welcome you, sir, for the presentation. Thank you.
A very pleasure meeting to all, and this is a 1 second, please. Very pleasure meeting to all, and I'm really very happy to connect with you. And thanks for a great opportunity on this very good platform. So, and I personally appreciate Guruswami, Professor Guruswami Garu. So, because he approached me for a few days back, and he asked me this lecture. But due to busy schedule, I unable to give some of the content also. But sorry for that. And this presentation, particularly, I share my view, my experience on what I have seen. So I cannot say that this is 100% is a complete presentation, but I can say this is one of the approach what I have seen it. So any project in my career, I have seen it like any topic, or in particularly electrical sector, I've seen like you can view in an academic viewpoint of view, you can view in a higher education viewpoint, and you can view the same topic in an industrial viewpoint, and you can view the same in a business opportunity viewpoint of view, or you can view through your innovative approach viewpoint of view. So in this presentation, whatever I am sharing is my experience in industrial as an industry professional while working with the same equipment. I'm explaining to you. Yeah. So first, already I've seen that 5-day schedule, and in a 5-day schedule, you have seen it automation view and protection and many more technologies and recent trends and everything. So in all these things, whatever I've seen it, these all called for the controlling of the particular industry or particular plant or particular system. Like you can take the automation and all. If you need a automation, means in olden days there is no automation, it is all our local control. So if you need a automation, means you are expanding the system because of the complexity is increased. So accordingly you need to update the things, so you introducing the automation systems. So when you introducing all these things, so main question is the reliability. So how much reliable of your system? So the reliability will come through your power, means continuous power supply to that item. So for that purpose, in every industries, we have UPS or charger for industrial applications. In particularly crucial plants, like suppose oil and gas industries in offshore or onshore. So we are handling with gas export temperatures, and also we continuous of the supply and safety of the system or safety of the personnel, very crucial. So in these projects, we are handling that UPS and charger. I'm explaining to you. So where we use it, already you have seen it in substation control system, you need a supply, and your protection relay, you need a supply, and your some emergency lighting, you need a supply, or any circuit breaker tripping, you need a supply. So all these things, whether some emergency lighting I mentioned in this slide might be, you may take it from the battery source or DC bus, or you may have internal batteries for that. Okay, so I'm not talking about internal batteries here, I'm only talking about the your feeding from DC bus. So these are the areas you regularly you need a DC supply. So for that, you can say it's a some of the continuous loads, some of the momentary loads, some of the non-continuous loads. In an industrial plant, if you see it like a continuous loads, like indication lamps, some communication systems like PAGA systems, these are very important, and emergency systems. So some emergency lights, some continuously energized coils, where you need a tripping supply, continuously you need it. When you lost supply, and breaker will trip. So meaning that you need continuously the power supply to that coil. So these are some of the non-continuous loads. You can check it, non-continuous
Excuse
loads.
me, Suresh.
Yep.
Can you please keep a full screen mode? Some people are not able to see, it seems. Sorry to interrupt. Yeah, thank you, Suresh.
So these are some of the momentary loads. Suppose momentary loads, particularly, you can see it, circuit breaker tripping. So circuit breaker tripping, generally, you know it already before maximum 1 minute. So the meaning is that, so the initial, so first initial, it will be very high. And after that, it is a continuous loads. So momentary loads are like some peaks will come in at some point of the time. So why we need all these loads? So I will explain in a later session. So why I mentioned all these loads, types of loads, and everything. So I will come into that my experience viewpoint of view. When I worked as a design engineer, my interpretation. So you have seen a UPS inside it, like your PWM technology or diodes or integral, some many electronic systems, part of your electronics, power electronics and other subjects, and digital electronics and all. So, but all the things are integrating inside, and now you are an electrical engineer, you are viewing in outside, and you are using that equipment. So that is what after my completion and after many years also still struggling of some areas. So specification, the equipment specification is the most important thing which before you starting the project. So if before starting your UPS, and you need to open the specification clearly, and you need to check that what is the configuration we specified. Again, here you can see in a different view, like if you are a company side, client side, you will issue a specification, and after that EPC engineering or design engineering guys will review it in their viewpoint of view, or vendor viewpoint of view also, again he will review it. So equipment inside what configuration he requested. So I will explain what is the configuration. Suppose every configuration, every word in a specification is related to your cost. If you mention anything, some simple, some wrong also, and it costs more. I have seen the real-time experience in that specification. While specifying the equipment, they mentioned as a 50% of the battery usage for unit 1 and 50% unit 2, but wrongly they mentioned as a 100%. Their viewpoint of view, 100% 50-50, but vendor in specification you wrongly provided, vendor provided 100 and 100%. I will show the configuration, and you can check it at the time. So then what kind of batteries you specified in it? Like in industrial application nowadays, many previously you have lead acid batteries and all, but nowadays it is like all need a maintenance free batteries. So I have seen in my first project nickel cadmium batteries I used it. Now VRLE type batteries I used it. So next is the battery autonomy. So how battery autonomy will decide is, you need to first understand what is the battery sizing. So for the battery sizing, you need to check what is your loads. And this is again a different topic and different sizing, and you can see it online also, many battery sizing criteria, and particularly IEEE 485 and IEEE one more IEEE has defined it how to size a battery. So many industries are following the IEEE 485. So these are the loads we will prefer, and based on these loads, we need to be calculate what is your load, how much time you need it. Suppose in the first 30 minutes, 30 seconds, you need some momentary loads, or 1 minute you need a momentary load, or continuous load, how much you need it. So each and everything you need to be define your battery cycle clearly. Then you need to size what is your loads are impacting on required for your battery, and based on that you need to size your battery with using the IEEE standards. So, and based on that, after finalization your battery, and you need to now fix your what is your battery autonomy. And second, after that, you need to check what is your battery recharging time. So like you can say it like 80% of the feeding, 80% of the charging position, and what is the voltage. From that point, you to reach that 80% of the battery charging capacity, how much time you need it. In industry, two different criteria are there. One is 8 hours and another is 10 hours. So up to you, like what is your industry requirement, and you can check it. So what is the recharging time? The next is battery tripping and alarms. So when battery is tripping, when battery is tripping is a very important criteria. To you cannot discharge the battery like your phone. In your phone also you can use your battery until 10% or even 1%. But when you are working in a also, so because that impacts on your battery performance and long life. So battery is a very smooth item. It impacts with your temperatures and your atmosphere conditions and your uses. Everything means charging and recharging cycles. Everything is impacting. So you cannot change also batteries suddenly, because if you define any oil and gas project, it is a 40 years project. So 40 years, you cannot change the batteries in a middle time. So when you specify it, you need to mention these things very clearly. So what is a battery tripping? So what level it is we are tripping. Okay, that is important. At the same time, what kind of alarms are generating in UPS? Like if you say that if you are operating in any mode, it has to show in on your user interface or your HMI, or it has to go to your some remote control systems, like you can say it's some PCS or ICSS or DCS or your SCADA. So anywhere you need to be for remote location, you need to get the information on battery condition or battery operation or some alarm levels if the battery is deploying, and you all these things you need to be specified in your specification. At the same time, charger also. In charger means or UPS means, I'm not talking about a simple item. And inside content module, you have a electronic circuits, and you have a small transformers, and you have many static switches. Again, that is also electronic, and all these things. What kind of alarms or tripping systems you are providing also, you need to be specified. Means based on this all information, you need to approach vendor, and when you need to request that this is my specification and this is my requirement. So specification is a crucial item when you start a project. So that is what I've seen. For that, where we can see it. So you can approach any vendors, and you can approach the vendor manuals, and real time you can see it, and what practical, what in academics or in our textbooks, what it is mentioned, you can see it. And my viewpoint of view, after observation few years, the many times in textbooks, particularly either design means manufacturer viewpoint of view, our textbooks are there. But when you are working in industry and you are the person you are the person like manufacturing engineers are very few people. Like in vendor factory, very few people are working. majority of engineers are from EPC side or design side people. So they are application oriented engineers. Well, like if I receive a battery, or if I buy a battery, and if I buy a charger, and how to specify it. So that is the reason, and the best approach is we need to open our manuals, and particularly vendor manuals. And I will also forward some of the manuals for you people if you need it. So this is the best approach when you compare with your textbook. So after that, sizing calculations. So charger sizing, and I explained it. I will explain later how to define a charger sizing, and inverter sizing, and hydrogen gas leakage calculations. Why we need it also, I will explain it. So this is as a design engineer, I need to look all these things in the initial phase. Once after completion of these ones, and I can now think like your construction or commissioning engineer viewpoint of view. Any clarifications you required on this area? Or end of the session, you may ask the questions.
Yeah, Suresh, at the end of the session, we have question and answer session. So where
Okay.
we'll post the feedback form and the certificate form.
Yeah,
also.
perfect.
We'll
So this is perfect, sir. And this is as a design engineer, I have seen these are the crucial items while working. So like commissioning engineer interpretation. So when I worked as a commissioning engineer, and I looked at how to commission the battery. So I've seen it, my experience. So when you write a specification, you doesn't mention when to deliver onto site. So this, how it is impacted technical versus cost. So battery, we ordered and we received a battery. We completed all engineering and we reviewed all documents and we approved it, and they delivered on site, and we started receiving the material. After material receiving, project on board installation and start commissioning work, it is almost 8 months. During 8 months, batteries are in warehouse and batteries are not charged. So the meaning, after 8 months in battery manual, they written as like you can store any battery only 6 months period. After 6 months, if you want to use it, you need to charge back the batteries, or some batteries may damage. So this is the first experience I faced it. So then again, if I change the battery, and again you need to send back to factory, and they will open up, they will fill the chemical, and again they will test it, and they will send back, and it is a long process. So means that again project schedule is impacting. So your technical terms like how to store the battery, and what is the temperature is a storing location is required. So batteries are ideal condition always. So means that maybe it is 20 to 25 degrees, vendor will specify it. So in that period only you will mention. You need to store the battery, and you need to store it like 6 months, maximum 6 months period. So this is a lessons learned in my first project, we failed it. So in the next project, we clearly mentioned in our specification, when engineering only we will finish it, and battery we will receive after only 3 months before we will give a notice. So the technicality and cost and deliver, how it is impacting is like these kind of smooth items. If you are like a transformer, if you receive it on site 6 months or 1 year, doesn't problem. Or cable, if you receive and if you store properly, no problem. But these kind of batteries are very simple, smooth batteries, so it will impact. Again, UPS commissioning. So UPS commissioning phase also, and a lot of work we need to be verified while doing the commissioning, and the cost is impacting. Like if you miss any comment or any proper approach, if you miss it, and you need, again, the technicality will impact. Like example, I will tell. So my side, when I want to start commission my UPS, and UPS will give a signal to battery to trip the breaker. So that to trip the breaker, our engineering guys has forget that coil and the power supply. So that again, you need to modify the whole concept and you need to update it, the whole concept. So the technicality on each and every item, when you buy that equipment, but when you are in a design engineering phase, you don't look at how to complete the job. But when you are in a commissioning engineering, how to say you had a battery and you need to prove the battery to when you are client. So how to prove it means you need many auxiliary supplies. So these auxiliary supplies information, if we forget in a commissioning phase, and it is impacting on your cost of the project, like your load bank capacity. Suppose if you are bringing that some 160 amp hour battery or 1000 amp hour battery, accordingly you need your load bank. So load bank, if you are not specified properly there, and you need to be bear the cost. So commissioning spares, and to protect equipment, you had a lot of fuses you will install, and you have your PCB boards, and you had might be some charging circuits. So all these kinds will impact on your commissioning spares. Okay, you need to be mentioned specially what are the commissioning spares is required. And test equipment. Test equipment means suppose your battery, you need to check each battery voltage and internal resistance and healthiness. So for that you need a special test equipment to check the healthiness initially, and after some 8 hours commissioning or 10 hours commissioning or 24 hours commissioning, every time you need it. So some special equipment always required, and even this is not only for this this electrical equipment, you can take it for electrical equipment, same concept. So electrical equipment, same concept. So auxiliary power systems, and it might be sometimes you need a additional supplies, so you need to be check it. So temporary HVAC. When you are installing any battery in a particular room, I said before, and you are running a battery in a 20 degrees or 25 degrees. So if you want to maintain it, and when you receive a battery and you stored it in, after that you are installing. So when you are installing, you don't have any supplies, and if you see it in a substation or any power plant, and you don't have any initial power supplies, so that time how you will provide it supply HVAC. So then you need to initially think about temporary HVAC. If you doesn't have a temporary HVAC, what will happen? So in initial construction phases or commissioning phases, and might be some guys are lazy or some may not follow the rules strictly, and you start doing your charging application, and your battery will generate the hydrogen gases. So these gases So temporary HVAC is very crucial item when you are commissioning in a battery. And you always keep in mind, we need to be maintain the battery room always 20 to 25 degrees. So this is now we talk about the specification, commissioning approaches and all. Like now I would like to show the equipment. So particularly this is the configuration which I am using in my project. Okay, same, almost same. So you may have different configurations, like you may doesn't have this bypass unit, you may doesn't have this maintenance bypass unit. Okay, so up to you. These all things you need to mention your specification, what is your requirement. So example I will tell. So if you see here in project, this one, you need to connect your AC output with both UPS A and UPS B. So means that you mentioned in your specification parallel redundant. If you mention like this, means it's a single source. Only single UPS is supplying to your load. So the mentioning in your specification what you are specified is important. So now what is a normal input and bypass input, battery source? So like you had a almost here you had a 4 ways you can supply to your load. One is your normal load, normal input. This is way. And if you lose the AC input, you have an opportunity bypass input. And if you lose even bypass input, you have a battery source through this line. Don't want to use all these things, and you want to maintain all this. You want to go for a maintenance for all this system, and you have this source. Means that you have a 4 sources to supply load. Means that that load is very critical, and you don't want to lose it. If you go for this scheme, even if you have a lose of one complete unit also, you have a backup here. So the reliability means again you are increasing the double cost. If it is 100 and you are going for a 200, so that is up to you, reliability. And again you have I mentioned before that battery specification 50%, 50%. Your load is 100%. You may take this is 50% load and this is 50% load. Or you are very rich, you may take this is 100% and this is 100%. Okay, and you are very one. So like lot of options, lot of configurations, lot of availabilities you have. So up to you how you specifying. So only thing is that you are increasing cost, not only cost. If you mention like this is 100%. When you are in a working in a power plant, and no problem, because you had enough space, enough space you have whatever you want. But when you are installing the equipment in an offshore platform, you have a limited space, and main criteria is a weight also. If you increase the load and your weight also increase, and accordingly steel, everything cost is impact. So when you specifying working in a project is very crucial, which project you are working, and accordingly we need to define carefully the requirement. So we no need to be compromised on your load, but optimum engineering is very much important while selecting the battery and while selecting these bypass sources. Because if you increase one more source, means from MCC you need to take additional line, so additional cable, additional breakers. So all these things you need to be, and it might be additional if they may need relay also, additional circuit breaker relays, all these things you need to be. So all your configurations, your criticality, all is depend on your system configuration selection. So very carefully we need to be think on this. So this is your application. You know already this is your rectifier unit, and this is your charger unit, and this is your inverter unit. If you see it, this is a charger unit and this is a rectifier unit, like side by side. If you in a picture it is like this, but when you're operating the equipment, will be side by side. And at the same time, in the specification they will mention clearly, and both, if you are here, both should not be in the same room. You need to be specify the equipment in another room. And one more thing is, when you specify the battery, and you cannot keep the battery in the same room, because batteries are very sensitive. If any damage comes, your UPS will impact. So batteries should be in a little far, and you need to be take care very maintenance and all. So like so this is like representation here. So some people may go for the static switch, all these in another unit. So some companies nowadays, modern electronics and sophisticated, and so now technology is improving day by day. So they are keeping this unit also here. So unit size little increasing, and they are keeping here. So all these is up to vendor, and you can approve it. So this is your rectifier unit, and already here symbol also mentioned clearly, and you are changing from AC to DC, and this is your inverter unit, and you can change back from DC to AC, and you can feed to AC load. And if you say only charger, you no need of this item. So directly you can feed it through, because you need a DC supply only. So I have seen one practical problem. We operated the item, and here equipment is damaged, and we received a charger failure. So what is the problem means? We mentioned a battery supplying here. Why can't go to this direction? There is a possibility. Power current, you cannot say that this is only direction go. It may go this direction also. So for that, we installed one fuse and one additional diode. So even when you operate it initially, and battery in initial condition, it is a unidirectional approach. It will behave like very high currents will come in initial phases. So initial phases, the current entered in this direction and fuse has damaged. If you doesn't have a fuse, and it may damage your electronic equipment. So in engineering, last project, I faced this problem. In when I worked in India, they doesn't provided any fuse here. They provided only the diode, so forward diode. So but still, I don't know the damage of the equipment, diode problem, but current has passed. Because of this fuse, we protected this equipment. This is a very important, and it is if damage these PCB items, and it is a costly. And again, so to protect this equipment also, some project they had some pre-charging circuit here, and through pre-charging they are injecting slowly current to this electronic item. Okay, so this is what I've seen it. And after that, here I've seen very interesting thing is, this is a load. You may say that 120 volts DC you required, or here you may say AC. So you may say here 125 AC. So if you say 125 AC, and you cannot say exactly with the same one. I mean, like you may receive 130 volts, or you may receive 135 amp volts. So I will show you here. See here 134 volts, but actually your requirement is 120 volts. So where it is going, remaining volts, where it is a drop. So drop purpose, again, you need to install some of the diodes here. In this representation, it is not mentioned, but when you ask vendor, he will show it clearly. So they have diodes here, and diodes also have a switching facility. Like each diode had a separate switch. You can switch on properly one by one, and you can see it what is your load. If only one is required, and you can only use one line. If 4 volts reduce required, and you can reduce to include 2 connects. So like the way they reduced, and finally they are achieving your 120 volts or 125 volts AC. So this is the inverter, and this is your static switch. The main purpose of this static switch is, if you lost this one and you are saying this is, and if it is available again coming back to here. So like and you are again saying here is very reliable, and you don't want to lose supply any second also. So such a high speed, you need a special electronic switch to convert change from normal to bypass to normal. So for that purpose, they used it. So this circuit is mainly manual maintenance bypass. Very clearly mentioned here, name itself, manual maintenance bypass. So if you need this one, and you can move it to here and change it. So when you see equipment, I've seen like that in when theory and, but when I come to my in equipment, so after seeing real time, I've seen it in, like, we have a switches separately. If you want to move to maintenance bypass and move to maintenance bypass, and if you want to move to manual bypass and move back to manual, means like you had a three-way switch is there. Where the three-way switch is, they installed at here one three-way switch. You can keep it in a normal, you can keep it in a bypass, and you can keep it in a manual bypass. So accordingly, operator had a opportunity to move to any direction. So this is what we are using. So this is a UPS A and UPS B, and we are supplying to those. Yeah. So same main components means your charger, which converts from AC to DC, your inverter, and your battery, your static switch. So this is the way is the main components of this item. So if what is criteria if AC power loss? This is a question I faced it. So people say that if you lose AC power and immediately battery will feed a load. Is it true? Or if you lose AC power, bypass will energize? So this is a general confusion, and you need to ask vendor clearly what is a criteria if AC power loss. So is this battery always this is in a connected position, means battery breaker in a closed position. So if you lost this one, this immediately static switch will changes from normal to bypass, and bypass if failure, and battery will start feeding. This is a criteria if AC power loss. So this is the main components. I think I explained little bit on this. And if you see internally how the charger circuit inside, inverter circuit inside, in mostly in theory, in practically we may not see these ones inside, and you can watch inside any textbooks on related these things. Yeah. So I explained. So in operation, how it will behave means normal mode, bypass mode, and this one is called your battery operating mode or isolating bypass mode. So this is a normal operating approach. So now the one of the important thing is, like we say that here we had a battery, and we lost a power, and we lost this one, and we feeding this one. So, and in normal case, you are feeding this approach. The meaning of here, what is the charger is operating in this mode? We had in different vendors a different approach. One is a float charging, and second is a boost charging, and third, some guys may say equalized charging. Okay, so I have seen it, like in my first project, I don't have any boost charging specially. Boost charging word, he said it is like a first commissioning charge. So he is calling like float charging and equalization charging. What it is a float charging? Float charging means you need to feed the load in a normal operation, and at the same time battery had a possibility of the self discharge, because long time if you keep it, also I said before, I stored a battery in more than 6 months, and it's a deployed battery. So why? Because it is a self-charging. So battery had a capability of self-charging, and you need to be maintained properly. So how you maintain in a normal life condition? Because in power plant, if you see it, normally you may not lose any power. Okay, and if you lose a normal power also, you have a bypass source. After that, your battery is coming. Means that your battery is in idle position even in a power plant is operating time. So there is a chances of self discharge. So to maintain the charging, and you need to be feed little load here and remaining load here. So this is called float charging mode. Operation system is in a float charging mode, and this maintaining the charging, they may call it like a trickle charging. Okay, so this is called, it is like a float charging. What is a equalization charging? What equalization means, if your battery cell is operating at 2 volts or 2.2 volts or 2.25 volts, and you can ask the specification vendor, he will say that what is a cell voltage of an individual cell. So if you say that 2.25 volts, so is your float voltage. So at your battery voltage is 2.25. So, and if you say that boost charging time, your voltage level is 2.75. So until 2. You can charge at a 2.75. Okay. So if you say that battery is if you're charging, they may say again a gassing point. So after some charging point, it is they will say some hydrogen gases may start. So until that point, they will charge in a boost. After that, they will move to equalization, float charging. Some vendors, I will explain later that one. So this is your float charging method and equalization charging. So float charging is like you have already, means that your battery 2.25 is healthy condition, meaning that you need a very small voltage, means that your voltage is fixed. So float charging means your constant voltage you are charging. But equalization charging means already when you need equalization charging, after your power loss, you feeding it through battery, then you come back a power, then already battery is deployed 30-40%, then you need to come back to this charging battery immediately. So you need a high rate charging. So they will go constantly, they will send a high current and bring back to normal position battery. So that is the reason they will do it. But it is, and practically what I have seen, it is in the manual, it is written simply float charging and equalization charging. But when I have seen it, they doesn't use the equalization charging. So B means they feel like I don't lose immediately power, means I don't lost immediately power. Normal power I supplied a load. Normal power I supplied through this line, and I lost it all the sources, and I supplied battery. After 30 minutes, power returned. So you consumed almost 30% battery. So after that, you feel like, okay, I don't lose power for the next 4 hours. So I can run my unit with a float charging. If you feel it, if you feel that it may lost power immediately again, so I need to keep my battery ready. So then you may switch to your equalization press button and change your charger into equalization mode and quickly complete the charging. So modes of operation is up to your operator's view. It is not like mandatorily to charge any equalization. It is up to you. This decision is based on that experience. They may take a decision, like power system reliability viewpoint of view. They can take a decision. So this is I would like to show one display for you. Like this is a charger display, and Ametek is a supplier, and you may see it. This is a float mode. If you press the button in a float and you can press it. Okay. If how you can change a mode means if you want to change it to equalization mode, and you can press the button in equalization, so you can change it. So may come a questions like why to change a mode. As I said, is when operating the equipment in a normal phase, will you able to change a battery in equalization? Yes, you can change, because you had a facility, it will allow. But in previous designs, in when I was in India working in Tata, so they don't have like a float cum boost charger. They had like a float charger separate and boost charger separate. So float only for this purpose and boost is to charge always for battery purpose. Because so it will reduce the cost if you use same one, means float cum boost. So nowadays majority projects are float cum boost. So in the same future you have on the screen itself, simply you can change it to float to equalize mode. Only keep in mind, after power loss, always machine will think like, I lost a power, my battery is deployed 30-40%, so I need to charge back. So if you say it, if you have a auto feature inside, automatically it will transfer load from after power loss, power return, it will shift back to equalization mode. But if you say that auto mode, if you off it inside a computer, through computer only you can change it, or you can have a feature here, use these 4 screens and you can change it. So 4 buttons you can change it. If you had a facility, then you can move it. Okay. So up to you that transferring from float to boost or equalize to boost. Here I mentioned boost. You read like a boost and equalize are same. Okay. Float to equalize or equalize to float, up to you. Okay. After power loss, if it is in auto mode, it will be in a equalization come. If it is not in auto mode, always battery charger is in a float mode only. So this is a operational. I said like before, like they need a 240 volts system, and each battery cell is a 2.23 volts. And in a boost mode, each cell is at 2.75 volts. When float mode, it is at 48 amperes. DC continuous means 48 amps load is required plus trickle charging. So your charger had a facility to minimum this much load. So while sizing the charger, what is a criteria means you need to charge your battery plus you need to supply to your load. So that is the criteria while sizing the charging. Yeah, I explained it like constant voltage charging and constant current charging. Okay, constant voltage charging means it's a float charging time. We are using into constant current charging. So constant voltage charging. Why? Because battery is in healthy condition. So you no need to be charge the battery. So your main criteria is to supply it. So your voltage, cell voltage is in a float condition and 2.25 volts. So no problem. If you want to quickly charge it and you need to move to boost charging means constant current method, and you charge with high rate and quickly complete the charging. So these are the charging methods we use it. This is internal only. You may not see it. Only you press the button whether it is in a float or boost. So what experience I faced it while battery commissioning. So this is the battery, and what I've seen it is in the specification they mentioned it is like each battery you have a cells. So this is almost you can say it as 240 cells, and you may have a 120 cells. So some may have if it is a like a SCADA or control room, it's a very big battery room. You may have a 500 cells. So how you check the healthiness of the battery. So that is very crucial. You cannot go and check individual battery, take a multimeter, measure voltage everywhere, 1111, and you had some special meters we have now, and you can check it for even internal resistance also. You can check 600 times. You feel that which battery failed, how you know it? So very critical. So very logical. Like you are spending a lot of time there and to identify the failure battery. So if you start with a 1, if it is a damaged battery is a 400, so you need to be wait until 400. So battery is very crucial item, and you don't know where is the failure. So to rectify this issue, I have seen the project. We had a battery monitoring system. So individual battery we connected with a kind of sensor systems, and all the sensors we connected with module. From that module we connected to a computer and a special HMI, and we can view there which battery is healthy, and we can view it battery healthiness through that. And one more important is this is that, so when battery when comes to onboard, and if you have it, if you have a long storage, so this portion first bulk and absorption, and these portions vendor will complete at his site. If you doesn't have this, if it is a long storage, it's more than 6 months, then you need to start from here. Means that you need to go for all 4 phases on site itself. So battery, what condition is coming also very much important, and what level, how much time it is storing also very much important. So in initial phases, see, it is a constant current. This is your constant current. So this is when you measure it, when you are coming with your constant current, and you are increasing your cell voltage from some suppose 2 volts, some slowly increasing to your 2.25 volts, then you are maintaining your voltage here. After that, again, this is your condition, your float voltage and your equalization voltage. Float is 2.25 and equalization is 2.75. So this is the way your battery 4 cycles. Your 4 cycles you can view from your battery monitoring system through healthiness. With that, what advantage you will get it is, because you are calling a vendor to commission this job, or you will do the job, so man-hour count will come. If you are not verifying properly, and one day it's a project schedule, man-hour schedule, all will impact. So battery monitoring system is very crucial item to check the healthiness and your cost. So this cost can afford with this battery additional equipment. So this is what battery room we say that, and we say that temporary HVAC is providing. So if I lost HVAC, if I lost my power, if I lost my ventilation, what will happen? So you lose your ventilation, means that your battery, if you charge battery during that time, it is a high gases point, and you are already charging in a battery at a 2.75 volts, like higher voltage you are charging, there is a high chances of gas leakage. So that is the reason you cannot charge a battery while if you lose a HVAC. So only you can charge the battery when you have a sufficient HVAC in your room. So that is very important. Or if you lose HVAC, what will happen? You don't want to charge the battery. So you don't want to charge the battery means what? So you don't want, if you doesn't have this supply, and happily you can you don't face that problem. So when you lose ventilation, and in your scheme drawing, it has to trip this breaker. If you trip this breaker, and you cannot charge the battery. and only you can feed load. You can, okay, no problem for feeding a load. Only if you lose a ventilation, you will trip the incomer breaker. So that is what I have seen it. So, and I explained what is the advantage of your battery monitoring system. If you doesn't have battery monitoring system, also no problem, because you can happily measure the individual voltages of cell individually, and you can do it. No problem for that. So this is what I prepared it for you people. So if you need any questionnaires, you can start asking, and I will share some of the material after this one, and I will show to you. This only the presentation which is I faced it, okay, as an engineer I went while working.
Thank you, Suresh.
Yes, sir. Thank you.
There are few questions being asked, Suresh, in the chat box. I'll ask one by one.
Yeah, sure.
This is question from B. Amarendra Reddy.
Yes, sir.
The question is, what are the critical parameters to be considered for designing a non-standard battery, and how to validate for specific requirements?
Again, sir, question.
What are the critical parameters to be considered for designing a non-standard battery, and how to validate for specific requirements?
See, while selecting your battery and what application we are going for, it is important, okay, and what kind of load you are using is important. So if your load is accepting that if I lost battery also no problem, then you can go for the non-standard batteries. But if you lose a power, because some of the motors, when you are working in industry and you had a fire pump, so the local control you had you need to apply. Fire call and fire pump has started. But if you fail the power during the time, so you losing your system. So criticality is Is it clear, sir?
Yeah, right, clear. So we'll go with the next question.
Yeah.
Sir, what is the criteria to be followed while selecting UPS? Specify the UPS rating if the number of computers are 120 and standby time is 2 hours. This question is by M. Bhaskar Reddy.
So standby time is 2 hours, and see, so your how to size a transformer and how to size a charger is the same, and you are mentioning charger rating is UPS rating is in is the same. So when you say that it is in a battery side, okay, so while sizing are mentioning this kind amp hours means ampere means it is like how much load is required, and hours means how much time you are need to operate. Like you say that 2 hours, like if you say the 50 ampere you have, so 2 hours means that 100 amp hour battery you need it. Okay, suppose if you don't have a 100 ampere and 100 amp hour, and standardly they will say suggest 120 or 140, you can take it. Or if you have a 2 ampere 2 hours time, if you want to run it, and if you suddenly increase a few more systems, okay, so only increase to 400 systems, that time also your battery will run it, and it will not run for 2 hours, it will run for 1 hour.
Yes. Shall we go with the next question?
Yeah.
Yeah. Mr. Karthik Shiva has sent it. In streetlight system, we are converting to solar-based system, and how to calculate battery size?
Yeah, battery size is a very simple method. Okay, you just calculating your ampere load. If a street light, if you consider it is 100 lights, if you take it like simple, like how much current is for required for each light, you can ask the vendor, the light vendor, and he'll give that 1 amp, 2 amp. So if you say the 10 amps, so 10 amps your requirement, 10 amps. If you run for a solar, for suppose you need when you need a solar battery, how it will work means until 6 o'clock, and you don't need it. Okay, your solar panel will supply. After 8 hours means that your evening 6 to morning 6 you need it. So means that 12 hours battery is required. So you need to ask your vendor like 12 hours into your 10 amperes. So like 120 amp hour. This is example is up to your current only. Okay, if you have a only 2 ampere current, then 2 into 12, 24 amp hour battery is.
Yes. Next question from Kushal Bhatt. Who are the major consultants in battery module management?
See, battery module management or battery monitoring system. What is that? So battery manufacturers or battery monitoring system.
Might be they mean so, but they wrote it like that.
So battery. See, battery monitoring system is nowadays you can also come up. Okay, that is there is no big inventory inside. Is you need to take two leads and you need to collect information and you convert into that chemical energy into what is the healthiness. So if it is like a very good opportunity in India nowadays, no battery monitoring systems. I have seen only in French companies or US companies only. So if we have opportunity, generally battery systems, if we ask, mostly Alcad batteries and Emerson UPS systems. He is main in charge, and he is taking information from Alcad manufacturer, and that is even in Hyderabad also, HBL, Hindustan Battery Limited, and Amar Raja Batteries is from one of the major supplier. These three are major industry battery suppliers.
Yeah, I'll go with the next question. The next question is, sir, fuse is not stopped to reverse current. Okay, or else I'll go with the next question by Asha Kiran Mai. Sir, is track used for static bypass switch?
What is
track used for static bypass switch? I think the question is track used as static bias switch? Might be.
You can use it. So inside component, I cannot comment what is electronic inside. So I don't have any proper idea on that, how it is we are switching it. So, and I think I have seen it like something like inside. So I exactly doesn't know how inside. So I cannot suggest you that can be use it or not.
Yeah. This question is from Milind. Sir, what is constant current charging?
See, constant current is like your battery is you are deployed too much. So 80% you consumed it or 70% you consumed it. So immediately you charge the battery to ready for the next operation. So in application, we will mention it clearly on that, like battery 80% charging has to be completed. After that, immediately 8 hours or 10 hours duty cycle, it has to charge back and ready for the next duty cycle. Means that battery
Yeah, I'll go with the next question again. So this question is from Kasim from Nigeria. Sir, I want to believe the switching process is automatic. If yes, what are the automation components, devices, or systems used?
again, sir, question.
She wants to ask, like, is switching process done automatic? What are the auto components or devices systems used to make the switching process automatic?
That is the purpose only. In charger, you had a facility, and you had if you lost a power, your static switch always take your current input here. So it always measure the current input. If you lost the voltage, if you lost the voltage, immediately it move to bypass. Like it will sense the it will take the input, the voltage input, and it will change it. Once if voltage input is present, and it move back from here to here.
Yes, this question is from M. Bhaskar Reddy. Sir, is there any automatic switch to toggle between float, boost, and equalizing charging?
That is, I said, there is no automatic switch. Automatic feature you had, if normal phase, you are running the normal phase into float mode. If you want to run in equalization mode, it already derived it after power loss. Very important question he asked me. So after people say that if I move to automatically, I highlighted like auto mode enabled, and I can now ready to, after power loss, I can ready to change it to equalization mode. But there is one more criteria is, if you lost a power, how much time also it is important. When you lost power, battery, when start deploying the battery, and the timer will start. So the timer indication is connected. So if you had a more than 10 minutes loss, that you can fix it. Like some people will fix it to 10 minutes or something. So 10 minutes they will fix it. So 10 minutes after power loss, this float mode will become mode. It will feed and it will charge. Okay, that is thing. Then after return back to normal, so it won't convert immediately to float. Okay, that is again had an additional timer in the after equalization again come back to normal only after 24 hours. Means that even it is a fully charged condition also, still it waits the 24 hours. So if specification
This question is from Kasim, Nigeria. Any charge controlling device, what is the criteria for its selection?
So there is no other criterias. Only you had a float or equalization or boost mode. So we had only these features only in present, and this is only our requirement.
Yes. Okay, we'll go with the next question. From M. Bhaskar Reddy. Sir, is there any UPS in India which is remotely controlled and monitored?
UPS is remotely controlled and monitored means, see, UPS controlling means what? So you have here you had a input breaker. So that is from MCC. So this MCC, remote means what? Remote means only remote location only, like remote control room only, in the same plant only. It is not from the same. You may not go to nearby equipment, but only the future is what nearby control room only. So in the control room, you had all your MCC breakers you can control from remote mode. So through that only you can control through UPS. But UPS individually there is no box. Okay, and again you have a control feature. This battery breaker, it is wiring to your control room. So if you wire to that particular location, hardwire, and then you can control it. But there is no soft approach, any Modbus approach or anything they don't allow, because this is very critical loads. So critical loads generally they don't use any soft signals, only hardwire signals only they will use. So if you want to control like that, you can wire up to any control room and you can control it. You can change it all modes also through that. Okay, you had a here in charger room, charger port, they had some connection they had. So you through that one you can change it any mode. So but you wiring you need to be done before itself.
Yes, this question is from Mr. Devadas. So what type of earthing system is required for industrial UPS, as the DC negative is common and neutral is on the AC side?
See, earthing means generally very good question they ask. So generally in industry loads, we use TNS or TNC. We use it, and sometimes we use it for IT systems also. So because it is a floating neutral, right? So when you lose it, main incomer here, it is in a float mode. So through this DC, you are connecting into IT mode, and IT or TNC or TNS, up to you. In specification, what is mentioned. Same problem 2 days back we faced it, and we faced it like the vendor is I don't know, forget or the thing, and he doesn't connected that earth link. So and like your protective earthing, they didn't connected. Only neutral is connected, and they forget. So we opened the drawing and we verified it, and there is some systems they had a TNC system, some they don't have a TNC. That is, some is TNC system and some is TNS system. So yeah, up to use based on your continuity of the system. And earthing is low voltage earthing is up to you only choosing that. And I will suggest one important book for you people. Snyder, they had a very good book on this one. Please read it. And if you doesn't have, ask me. I will forward that link to you.
Yes, sir. So, and I'll go with the next question. So from Bhaskar Reddy, what is the protection that you use against battery overcharged or low discharged?
See, battery overcharging, you had a, this is here. This is here, you see, you have a breaker here. And again, they doesn't mention here, they had a breaker here also, because battery breaker is in another room, right? And this is in another room, battery is in another room, or this is in a same room, might be different location. So you had a battery breaker here and you have a breaker here. This is very important question he asked. This is engineering impacted question, okay? So in my last project, what we done it is, if this kind of conditions, low DC means only alarm we will give. Low DC means like some may say that imminent shutdown or battery isolate means end of discharge. Like if cell voltage is a 1.75 is a high last one, so you need to trip the breaker. So 1.75 before 1.8, you need to give alarm. So that time, if wiring is important, if you wired your from here to here battery breaker, this will trip. So this is internal unit, and you had one more breaker is here, so they may trip that one. So up to you. So this breaker or this breaker, you should ask to vendor, or you should ask to your engineering team. like which breaker I am tripping.
Life
For
of an,
those kind of conditions.
this question is from Mr. Devadas. What is the general life of an industrial battery?
Because based on the project life, generally some people say 20-25. So if you ask for 40 years, then they will provide. So that is very important while specifying the equipment. So accordingly, battery will you need to choose your battery, and you need to choose your type. So that is based on your project requirement.
Yes. And this question is from Dr. Yogesh Yeshwant. What are the areas of research in the battery technology or supercapacitors?
So nowadays, mainly like big battery storage systems are coming. Recently, I have seen in Korea, they are coming even for a higher end battery storing systems. So and some of the applications like submarines have a different technologies. So this is a very good area. I will suggest that high end battery storage requirement and submarine storage, submarine batteries. These are the research areas if you look at, and these are very good areas also, and particularly submarine tech.
So this question is from Ragini Gaikwad. What could be another application with respect to float charging and boost charging?
Another application, I didn't means I don't know that clearly, but there is no another applications because your charger behavior and charger operating modes to feed the load and to maintain healthiness of your battery. So other than that, you are not using any other means. This charger is connected to this load only, ultimately, and this charger is connected to your feed your charge the battery. So we cannot divert it for this is for any other applications. So I cannot say that what is way of your interpretation. I cannot guess it. So I am not using this charger for any other applications.
This question is from Dr. Ayala Martanda. Trickle charging is best method among about two mentioned. I think he didn't question anything. So this question is from Avinash. Is trickle charging method is same as floating charge method?
Yes, sir. Both are same. Some people may say that trickle charging. Some people may say the float charging, and ultimately, trickle charging is the trickle current. Actually, you can say trickle current is that to maintain the battery. Means battery manufacturer, if you ask it, he will say that trickle charging because the trickle current is required to maintain the healthiness of the battery. But because battery manufacturer is different and UPS manufacturer is different. UPS manufacturer will say that he will call it as a float charging. So the terminology between the two guys only.
Yes, this question is from Mr. Devdas again. Do we select battery or UPS for transient starting current or continuous load current?
Both applications I said, right? So if you instantly in battery, 1 second, I will show one. I will share this file to you, okay?
Yes.
See, this is a transient currents, right? This is a battery cycle. This is L3 means your constant load cycle. This is L2 means you are again a small transient, and this is a big transient. So you are using battery for both applications. But that is a main problem because of these transients. And even if you need a 10 ampere battery, 100 amp hour battery, because of only this application, you need to be like a 500 amp hour battery. So, but you don't have any option, particularly AC loads always standard. Okay, AC loads is always standards, means your low, your lighting and your other, suppose your circuit breaker inside any 120 volts AC So this is no problem. But only problem with the DC charger batteries. This DC charger batteries, your battery is like your circuit breaker. You need to operate it for a first instant, again the last instant. Because of these two reasons, DC charger application batteries are a very high capacities, even for a low load requirement. And proving this one is very big task while commissioning. So if you have a constant load and you can prove it, like how much load it is, like 100 amperes. So recently we have faced the same problem. This is like suddenly you had almost how much, it is a 50 ampere current. So this is in this profile 50 ampere current. You are how much time you are using for L4 means time is for like 10 minutes. Like this is not correctly mentioned. This is a 1 minute. Sometime they will mention. So like this much feeding is very high. Like this is 40, but this is example one. When you see the real time, you need to apply 400 amps for 1 minute. 400 ampere, how you will supply it? 400 ampere. So you need to have your load bank, and how you need to big load bank again. So transient loads it will supply, but this is a criticality. Is problem is your battery size will increase a lot.
Sir, this question is from an user. What is the accurate measurement of battery capacity?
There is no accurate measurement. Means you need to be calculate the battery sizing, okay, and you need to know the exactly loads. That is a very complicated thing. Is that when you start in initial project phase, like suppose you are into one power plant designing. So when you are in power plant design, the day one you don't know what are the modes, and you don't know what is a control panel is required. Suppose one mechanical guy need a control supply. You don't know the control supply there. So that time what you need to say that you don't know what is the load. So you exactly loads you don't know in initial phase. So very complex to size the battery in initial phases. So always they will assumption only. Suddenly if you increase the load, and if you say that some control panels you need DC, so suddenly again you need to change the battery. So that is a reason battery sizing we will do initially something, and we will wait it until end again. So end of the engineering phase, again we will review the battery sizing. So everywhere this is a common problem while industry we will work. So we will say again the cost implications, many things will come, but we don't have any option. Again, if you say that 100 ampere battery, okay, I can I don't want to go all these complexities. I can go for a 500 ampere battery. Means again cost is impacting and weight is impacting. So everything is that you are an engineer, we are engineers, so we cannot go for unnecessarily high cost. Then there is no meaning of any engineer. So engineer we need to think as like optimization. So we always think that what is our exact requirement. If you are a really very good engineer, and you will think that exact requirement. So if you don't want to take a risk, so generally guys will don't take a risk. So in companies, so they will say that go ahead with the next level. We will take always these ambient conditions and additional contingency of 20%, and accordingly, even if you have a load of 20 amp hour, and with the conditions you need to take the temperature compensation, because still you are providing HVAC system, but you while calculating you will measure the 1.2. Additionally means 20% you are taking for that. Again aging. So again means like one person asks us 25 years or 40 years. So aging is one of the criteria while sizing the battery. So again 1.2 multiply 1.2 times. So each factor you are multiplying and you are increasing size. Okay, and additionally you are almost 30-40% you are capturing. Still even that also we will face a problem sometimes.
This question is from Dhananjay C. Yeah, this question is from Gopal Venumadhav. any industry is really implementing artificial intelligence application to UPS?
What is artificial intelligence? So why I need all these things? If artificial intelligence is active, means my feeling artificial intelligence or machine learning, we are supplying power to them only. So why should they want to observe our activities? So only artificial intelligence or data science is to calculate all your data and to prepare some algorithm and to build it. So my viewpoint of view, artificial intelligence will not help anything in UPS areas. Yeah, you are not analyzing any data. And if you say that breaker and you are taking the multiple inputs and you are capturing and you need to be for a better understanding, you may go it. Okay. So digitalization is coming up everywhere and digital substations and everything. But UPS case, you don't need much inputs. So you are not analyzing any data. So if you are not analyzing any data, you don't need much importance.
Yeah, okay. This question is from Asha Kiran. Asha Kiran Mai. Sir, in parallel redundant mode, after UPS, why parallel thyristors are used? Aren't they need to be anti-parallel?
Parallel thyristors, they are for that inside switching sequence they mentioned it. Okay, so I said it right, that is a switching sequence purpose they used for those thyristors only. So I inside I cannot comment much.
We'll go to the next question, sir. This question is from G Manohar. How can we differentiate ultra capacitors and battery in view of storage systems?
So this is like in industry, you had almost together you can consider it like 500 amp hour or 1000 amp hour load for the DC. Remaining is majority is you can run with your normal condition, and those are not critical conditions. Okay. And only you are feeding all these battery or UPS only through your critical loads only, not for running normal fans. Even in your home also, when you design any UPS system for your home also, you are designing only for few loads only. You are not designing for a whole house purpose. Okay. So if you design it like a capacitor one day, if it comes for the cost is matching, then definitely they may prefer it. Okay, because of the more advantages. But at this stage, I don't think so. They will prefer it. It's a matter of cost only, preference.
Yes, sir. Sir, there are many basic questions being asked. So we'll go to few questions only. So the question is, isolation transformer were generally preferred for UPS. However, nowadays there are they come with UPS. What are the reasons?
They will install inside it actually. Okay, they will install isolation transformer inside. You had two isolation transformers they will use it. One is a bypass circuit they will use it, and one is isolation maintenance mode also they will use transformers. Okay, so mainly to rectify all these things, and they are using only separately coming means that much size is not required. So small size, this much, I can say that this much box actually, that much box purpose, you no need to be go for again one separate module, and space is problem. So if you had again a transformer and you need to be again protection device, safely you need to install it. If you don't want that place, and you can install it separately, it doesn't matter, but place is issue.
Yes, sir. With that, we close the session with question and answer session. From
People
Triply.
want some material, and you can follow up jobs viewpoint of view also, engineers factory electrical in LinkedIn page, and few of our professionals they are maintaining, and they are keep on posting many jobs and many these kind of documents also, and you lot of documents available in LinkedIn page, engineers factory electrical, engineers factory electrical, you can see it. Lot of documentation is available. If you want it, you can use it, and many some technical informations jobs they are posting, you can use it opportunity. Okay, thanks for that great opportunity, sir, and I'm very pleasure meeting to you all.
Yes. Thank you, Suresh, for answering so patiently for all the so many questions which are being asked. So I think we come to the end of the session. So I request Mr. Sudhir Kumar, Assistant Professor from EEE Department, to convey a vote of thanks.
Good evening, all. Thank you, Mr. Suresh Vengali, sir, for your wonderful presentation. Today's session on UPS or charger for industrial plant is very informative, and also discussed the purpose of batteries in substation or power plants. You also shared your experiences and role of design and commission engineers, which are very important for us. Thank you so much for spending your valuable time to share your knowledge with us. And I brief about this international online 1-week faculty development program on industrial relevance of electrical engineer. On day 1, Mr. Shivaspurti sir, Senior Manager at NTPC, given practical knowledge on electrical equipment commissioning and maintenance. And in the day 2, Mr. Anup sir, Principal Engineer, ABB Power Grids, given a lecture on substation automation using IEC 61850 standards. And in the day 3, Mr. Rajshekar Uchil, Senior Manager at ISA, Bangalore, given presentation on vibration and noise measurement analysis and applications, and also discussed research areas on this topic. And therefore, Dr. Bakranjan sir, Senior Researcher, International Solar Energy Institute, Uzbekistan, shared their researches which is going on their institution and discussed about design features of automation photovoltaic stations. And in the day 5, Mr. Rashekar S, Head Training and Documentation, Open Systems International, Bangalore, shared about present challenges and latest technologies in his presentation about research trends in electrical field and power system automation. And in the day 6, Mr. Suresh Vengali sir, electrical engineer, Samsung Limited Korea, shared your personal experiences on DC systems for industrial plant. Thank you so much for that. On an average, around 375 participants had attended this FTP actively. Thank you all participants for your patience listening. And I thank management, principal and HOD EEE for arranging such a session to enlighten our knowledge on industrial exposure. Thank you all once again. Please fill feedback form posted in the chat box, and also given another Google form which will share in the chat box for details of certificate. Thank you all.
Thank you, sir.
Thank you, Suresh sir. And I request all the participants to fill 2 forms today, feedback form for today's session and also certificate for the overall feedback, for overall FDP. So all of you don't just fill up the feedback form today and just leave the session. Fill 2 forms. One is for the certificate and other is for the feedback. Ensure like you have filled 2 forms today. And for the regarding to the certificates, we'll mail you the certificates by looking at the active participants in the FDP. Soon we're going to mail it, and mostly in 3 working days we are going to mail you the certificates. So thank you all. Thank you, Suresh sir.
Thank you, sir.
Do any of the participants wants to give feedback orally? They can raise your hand so that we can unmute you.
And I would like to say one thing, sir. And I attended 3 days, a very short time. And really, you people done a great job. And this is a very good approach. And this kind of opportunity, please provide to your students also. So like they will get a more practical approach from studying viewpoint of view. Okay.
Yes, sir.
So,
Surely, sir. Sir, next week we will plan with you, sir, regarding to that career session for electrical engineering to our students. So might be next
Sure.
Saturday, if you are free, I think please spare your time to our students for 1 hour so that you can guide our students.
Sure,
in
definitely.
electrical industry.
Yes, sir.
So participants, you can share your feedback orally if you are ready.
Can I speak, sir?
Yes, sir. Sure, sir.
Dr. Yogesh from Kamala Institute of Technology and Science. Hello.
Yes, sir. We are able to listen you.
Okay. I'm audible. Yes, sir. Actually, this is a very good program, sir. Faculty development program related to the industrial relevance. Nowadays, AICT is also insisting for 1 month industrial training for each faculty. And this is a very timely program you have scheduled, sir. I am thankful to all the organizers, and all the sessions were very good, sir. Like in faculty getting the industrial exposure is very nice, sir. Practical things we could learn. I have learned so many things in all the 6 days, sir. Thank you, sir.
Thank you, sir. Thank you.
Thank you for organizing this program, sir. Thank you.
So any more participants want to share their experience? Amarendra Reddy, sir, can you share your experience?
Hi, I'm Navya Samudrala. Can you please hear me?
Yes, ma'am, we can hear you. Carry on, ma'am.
Yes, I'm Navya Samudrala from JNTUH College of Engineering, Manthani. I've attended this FDP, and that is so impressive. We have learned many new things from this FDP, and we have also learned how to conduct and how to implement all the things which we have learned in this FDP. And one more thing is, as the time is very short for us during this Corona time, so I've attended only 5 days, and I've learned many things. And I thought I've missed 1 day. So it's that sort of presentation given by each and every resource person. And I really thank the organizers for giving us such impressive session for us. And I would like to request you all to please conduct more sessions as this. Thank you so much.
Thank you, madam. Thank you.
Thank you, ma'am. I think Amarendra sir wants to speak.
Good afternoon, all.
Good afternoon, sir.
Actually, you have conducted this one in a systematic way, but thing why I have heard a small thing that the schedule is district the same. Given having 1:5, you are conducting a 3:30, 3:45 like that. While attending some of the webinars, farm workshops, what I observed, exactly the time at which they are telling, they are organizing at the starting at the same time, and exactly they are ending at the same time. This is what I have observed. The difference between the attitude and maybe some other countries. So are conducting excellent. I that one person from control, Rajesh sir, who is industrial expert in automation. That's very nice, and is a friend of some sir. So that session, that since I am control back, is useful. So thank you.
Thank you, sir. Sir Dhananjay, sir, you want to speak?
Yeah, I'm Dhananjay from Maharashtra. I'm CEO at Institute of Technology, Lonavala. I have attended all the sessions, but especially today's session was really helpful for me because recently we have changed our curriculum for second year engineering, and in that battery storage system is one of the major topic. So today's session is going to be very helpful for us. And I request to you all that the session was organized very nicely and a perfect timing, and the platform was also nicely managed. And I wish you will inform us for such sessions in future also. So thank you very much.
Thank you, sir. Surely we'll inform, sir. Sir, Pradeep Kumar Verma, sir. Pradeep Kumar Verma, sir, do you want to speak? Pujara JB. So thank you very much, all of you, for giving the valuable feedback.
Pujara JB.
Pujara, you want to speak?
Hello.
To hear you.
Hello. Yes, sir.
Yes, we can hear you. Please continue.
Yes, thank you very much, sir. This time was very useful for us. I am from Gujarat, and all speaker you have selected from various industries. We really very helpful content delivered by them, and please inform us for future program also.
Hello. Duly informed.
Yes, thank you.
Hello.
Azam, do you want to speak?
Hello, everyone. Hi.
Yeah,
I am Azam Omar from Sudan, and I'm working for the Sudanese electricity distribution company. I have joined this beneficial course, and I have attended all the sessions. They were really extremely beneficial and informative for me, especially in my field, distribution, and especially for the sessions of today, as I'm working for the substation and the session of substation automation as well. So all the sessions were beneficial, and I'm thanking you very much. And this was very helpful for me. And I'm looking forward for next session organized by your college. And thank you. A special thanks to Professor Grossori because he invited me and my friend because we recently have been in Hyderabad for a course and we met him. So he gave us now this very nice invitation with all professors and doctors in your college. Thank you very much from Sudan.
Thank you.
Thank you, Azam. Yes.
Good afternoon. My name is Ravichandra. So I am the student of MTech from Specification College of Engineering. Host and the organizers committee. So this is a very pleasure to share my feedback that I am doing my MTech in the CRD College. This is the FDP session, which is the contribution and the learnings is a great experience for me to contribute in my academic in MTech. And this is the FDP. I attended so many FDP sessions in recent days. This is the one of the best FDP session which has maintained the timelines and what are the starting time, ending time, and between the question and answer sessions, you have given the sufficient time to the participants and to get what are the required queries. So I will personally, I am so thankful for the giving the opportunity to join in this excellent FDP. And in the future, please give an opportunity in further FDPs also. Thank you very much, sir.
Thank you, sir. Thank you.
Hello. Hello.
Yes, sir. Continue, sir.
Hello. Hello.
Yes, sir. Devdas, sir, we can hear you. Please continue, sir.
Hello. Yeah. Thank you for taking me in, and I enjoyed this. It was quite a refreshing one, and every speaker had been good, excellent, and very proficient in their fields. I thank you for you all, and you're great organizers. Thank you very much.
Thank you, sir. Thank you.
Muthukumaran, sir.
Sir, it is very happy to see that you have been conducted this 1 week training program. So I actively participated in all the program, all the 5 days, 6 days. So today's session was very fantastic and it was very good explanation given by the Suresh sir. So all the 6 days, the presentation, everything was very awesome. It seems to be like a very practical oriented thing. So physically, personally, I got a lot of input from this thing. So thank you for organizing this kind of wonderful FDP. So once again, I was thanking all the college people and the management for conducting this kind of wonderful FDP, sir. Thank you.
Thank you, sir. Thank you.
Thank you, sir. Okay, no one raised that.
Thank you all the participants from the BVRITH Hyderabad College of Engineering for Women Organizing Committee. Thank you for your patience, listening and participating. Thank you all. Don't forget to fill the feedback form and certificate form. Thank you all. Suresh sir.
Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, Suresh.
Sir, I'm leaving.
Yes, sir. Thank you, Suresh. Bye.
Hello.
Speak. Yeah, Tasim, continue. We can hear you. Unmuted. Aapni WhatsApp channel.
Can we leave, sir? Sir, can we leave?
Please fill both the forms before you leave, ma'am.
Yes, sir. Sure. I have filled and submitted also.
All the participants, make sure you fill feedback form and form for the certificate before you leave the session.
Hello.
Yeah, participants, whoever are active for all the 6
Hello.
days will be given with the certificate. Yes, active participation in the FD.
Thank you for such a.
Thank you all. You can leave the session now. We'll end the session.
Sir, I was not there for one session. I couldn't because of low network problem.
Yeah. No problem, ma'am. We'll consider it.
Okay, thank you so much.
Thank you all.